This particular model is a RUUD system, RUUD, depends on how you want to pronounce it. It has a direct spark ignition, or what we call a DSI. So we're going to start down at the very bottom side here. If we were going to do maintenance on this, we need to pull this system out so that we could clean the motor. So what we're going to do is we're going to go through those steps. The idea is if you're doing maintenance, least invasive as possible. So one of the things that we do with that is we want to make sure we take as few things off as we need. So I need to get the motor out. So one of the things I'm going to do is focus on which exact wires do I need to focus on so I'm not taking a whole bunch of extra stuff off. We're going to go over all the things and components and parts on this IFC a little bit later. First, I just want to focus on what wires we need to take while pulling this blower. So here's our blower motor on the back, and we have these wires in this nice little wire connector. So if we loosen that up, these are the wires just for the blower motor. So we're going to start here, and this yellow wire is on a terminal called M2. You don't really need to know what M2 goes for. We just need to be able to mark it. Yellow wire is on M2. Now, so you know what M2 goes for. M2 doesn't go to anything. It's a hold or a park terminal. It's just to use that extra wire. So in other words, this yellow wire is a speed that we're not currently using, and it's just to hold that wire out of the way. Either way, we marked yellow was M2, so now we can take this wire terminal loose. We want to hold the board, and this one is really tight to get off, which is good. We don't want loose connections. The next wire I have is my red wire, so I'll write down and make a note, RED, and that one is on a terminal called FAN. What that really means for us is if the thermostat is calling for fan only, just circulating air through the house, this unit's wired for low speed to be moving the air through the house. So we're going to take that one off next. And then the next wire we have is blue wire. So I'm going to write down blue, and it's on heat. So I'm going to write down heat. So what that means is this is the speed that we're going to be using for heating. So when the gas furnace fires up, it's running this speed for the heating cycle. We're going to unplug that terminal, and now we have this black wire left. So I'm going to write down in my notes, black, and that wire goes to the terminal, says cool. What that really means is when the thermostat has a call for cooling, the control board reads that through the Y terminal, and it puts the blower in the highest speed. Black is high speed. We're moving the most amount of air into that house. So if we move those wires, we see that we still have, oh, I didn't even unplug it. We have one wire left, which is this white wire. This is going to be our neutral. So we're going to write down white, and it goes over here to a terminal on the board called neutral, or in. So now we can unplug that wire. And it's best to use needle nose pliers to grab these wire terminals, and you want to grab the terminal itself. You don't want to pull in just the wire. And some of these older boards are going to be very difficult to pull off. So now that we got that off, our wires for our blower are separate. So what we want to do is move these wires out of the way. And on this particular brand, for me to get in there, I need to pull this blower out. So what I'm going to do is do the wires, undo the two screws that hold the blower housing. So we're going to undo screw number 1. And screw number 2. These particular screws are very short, so I want to make sure I use these same screws when I put that blower back in. So now I'm going to slide this blower housing out, and now I can get to the rest of the screws much easier. If I'm pulling this out, I see that it's getting very tight right here. What I'm going to do is I can just loosen this connection here, and I want to make sure I put these wires back where they go, nice and clean. So now I have a little bit more slack that I can pull this wire out. Now I can get to the bolts right here that hold this control board in. So I'm going to loosen that. Not really bolts, they're just screws. In this case, it's 1/4 inch. Most of the screws on these furnaces will be a 1/4 inch, or they will be 5/16. This particular brand, the RUUD brand, is famous for using 1/4 inch screws, which is very nice because you have the same exact nut driver for everything. So I've taken the 2 screws off from the top, and we're going to check to see if there's any other screws holding it on. And we have one more set of screws at the bottom. Now if I pull this out of the way, we see that we still have all these electrical connections on this limit switch. This is an auxiliary limit switch. This furnace is designed to be a multi-positional, and if we were to lay this furnace down, there could be a chance that the unit could overheat, and this is just an extra safety to make sure that if it gets too hot here, we also shut down the system. Instead of taking all these wires loose, we're simply going to take out the 2 screws, leave this entirely connected, and we're going to move the entire sensor out of the way so we don't have to worry about it. Now when we move this control board out of the way, we still have one set of wires coming over here. This is to our transformer. So we're going to take the transformer out of the way, and we're going to talk about some things on this transformer that are a little different than other transformers. But right now we're just going to take these 4 screws out and remove this transformer. So these screws are a lot longer. They're going all the way through that transformer, holding it to this little plate. Now this transformer is just going to slide out of this little housing. I usually like to use a cable tie or something to hold this bracket out of the way, but now we can pull this entire blower housing right out of the unit. If you can see now, this blower slid in these little tracks that are mounted up inside of here. It slides in, and this housing here needs to be cleaned as well. In this case, we have leaves in here, but there's going to be all kinds of dust and everything else that went through the filter, or improper filters, or if the case the customer didn't change the filter often enough. So this is going to be some issues. But also notice the insulation inside of this housing. I keep a shot vac so I can vacuum that out, but there's also a metal piece here on the sides, and it's only ½ an inch of insulation. So a lot of times they're installing these systems in the attic, and you get all the heat from the attic that's going right through this metal, right to that little bit of insulation inside this housing. So it's definitely an energy issue when you install these units in an attic. So a basement or in a closet is an ideal situation for them. Also, this one has the side cutout. If this was installed in a basement, this very same filter rack would be installed on the side here, so your filter would be on the side. That's also acceptable. But what we're going to do next, we're going to talk about all the components of this blower motor and how we would take it apart and clean it. So here we have our blower taken out. And on these fins, there's a lot of dirt built up on this. So we need to take this apart, wash it, and clean it before we put it back together. This is part of the maintenance that we do, is we take this apart and clean it. When we put it back together, you always want to spin these to see how well it's turning. This one has a stick in there making some noise. But if you notice that the blower wheel is turning pretty straight, sometimes you'll see them wobble like this, and that's where you know you have a bad blower wheel that you're going to have to replace. But also notice how the blower wheel should be centered between this housing right here. Sometimes I see technicians install them too close to one side or the other and allows air to bypass. This particular brand installs their blower housing with a very close tolerance, so it's usually not much of an issue with this particular brand. So if we're going to pull this blower, one of the things we need to do is separate this wheel. So what I'm going to do first is take my sand cloth, and I'm just going to sand up this shaft to make sure it's nice and clean. And one little trick is you can hold the sand cloth on here, spin the wheel, and it helps sand it for you nice and quickly. So now we can see that this is nice and shiny. I don't care about this end. This is what I'm worried about. So now I can take my adjustable wrench and loosen the set screw. So I want to loosen the set screw. It's going to need to turn this direction. I'm going to turn the set screw to where it's here on this side. This way, when I loosen this set screw, I'm pushing down to loosen it. Some people want to put it like so, or even here. Well, here I'm trying to pull up, and if I put it this way, I'm having to push forward, and if your hand slips, it can go into one of these edges and cut your knuckles. And we don't want to be cut. We want to be cut as least as possible, and preferably not at all. So I'm putting it like this, where it's facing down. I have gravity working with me. I use the palm of my hand, and I push down. Now if I slip off, my hand just goes down. There's no problem. So I'm going to put it on again, press again, set it again, and now I have complete control of this set screw. I'm not worried about getting cut anymore because it's already loose. Now one more thing I'm going to do is I'm going to push this wheel inward, and now there's going to be a little bit of a groove right there where I couldn't get the sand cloth. So I'm going to sand that last little bit right there, and I'm not going to be able to spin this wheel now because this housing, this squirrel cage wheel, the blower wheel, is shoved up against the side of the housing. So I'm going to sand this down to make sure it's nice and clean, and I'm going to turn it on its end and put a little bit of oil through here so that the oil will go through there to make that easier to come apart. So by turning it on its end, I'm going to use a high-grade turbine oil. What I'm going to do is take my adjustable wrench, and I'm going to grab the flat part of the shaft with the adjustable wrench, and I'm going to work the wrench back and forth, and what it does is works that oil all the way up inside that hub. Now we're going to look at this other side. This is the only brand I know of, Rheem and RUUD, that does their blower housings like this. And what they use is these thin pieces of metal right here, screwed directly to the motor and directly to the housing. Most units use a type of rubber that connect with the housing to a bracket. The idea behind this, and the reason they do that, is this thinner metal allows to take the shock of the motor. So when this motor first starts up, it allows for this motor to twist some, and this takes that shock out of it. But when we take this apart, we're going to have to undo all 3 of these screws on every single leg before we can pull this off. We're also going to have to undo this screw so we can pull the capacitor out. We want to separate everything electrical from this housing so that we can wash this out. Everything on this was a 1/4 inch except for this one screw that held our capacitor. This was a 5/16. One of the things that's nice is Klein makes this cool little screwdriver that has both sides to it. So it does 1/4 inch and 5/16. The only thing I don't like is it's just too heavy. So I fall back to my old lightweight nut driver. I've had this one for probably 25 years. There's tons of stuff out there. I did use a drill for this because it takes it loose very quickly. If you're putting screws back together, you want to make sure you use the torque setting on your drill so that you don't over tighten those screws. Notoriously, technicians will over tighten these and put them back in, and that strips all these out and it makes it pretty well worthless. So it's a big issue. You want to make sure you use the torque setting. The other thing is brand of a drill. It doesn't matter what brand that you buy, you're going to work with somebody else that doesn't like that brand. I'm a fan of Milwaukee. I also have a ton of DeWalt tools, but just get a tool, take care of it, see what works for you, and go from there. Now when we pull this motor out, I'm going to reach down and grab the motor itself, use the sides as leverage, I'm going to pull this motor. And ideally it will come right up without having to use any kind of puller. So here we go. Perfect. The reason it happens like that, it's not by accident. It's because we used our sand cloth, we sanded this shaft down, and we also used that little bit of oil in there. So that allows us to get this housing out. Now if we move our blower out of the way, let's take a look at this motor. If I was going to replace this motor, I'd have to also take these screws off of each leg and put them on the new motor. And when I do that, I need to make sure I get a motor that's compatible to this brand, because you just want to be putting any screw in any motor. If the screw is improperly placed, it's going to go into the windings. So I need to make sure I'm using a motor that's adapted for this, or use a universal type bracket that goes with it. If we can see, this motor here has all of this fuzz and dirt on here. What we're going to want to do is take our sand cloth and we'd sand this shaft all the way down. The bearings right here are at the bottom, and these are sealed bearings. They have the old casings for the oil ports, but you can't oil these. They're sealed for the life of the motor. Once these bearings go bad, you have to replace the motor. Don't try oiling these, and especially don't use any kind of penetrating. WD-40 has a product that's used for a lot of things, but not for these motors. It'll actually push the oil that's in there out, so it causes a problem. So what I want to do is check the motor bearings. So I'm going to hold the motor flat on the ground, and what I do is move the shaft back and forth. And I don't feel any play in the bearings, which is good. Up and down, you will have play, but we don't care about that. We're looking for back and forth. So this motor, the bearings are good. Now I want to look at the windings. I want to look in there and see if that copper looks discolored. A lot of times if you have discolored copper, it's an issue where the motor's been overheating. So we also want to take and clean this motor up. We'd use rags, we'd clean all this up. We'd take a CO2 tank or some kind of tank and blow a lot of the windings out. We also want to make sure we don't put too much air pressure here, because we don't want to blow any of that oil out of that grease packing. On this motor, we also see there's a little bit of a grease ring right here. That's a good indication that this sealed bearing may be losing some of its grease already. So what I want to do is note that in the service invoice. I want to note that the motor does show signs of leaking. Now this could simply be the last guy put oil in to pull it and clean it and it's leaking out. But either way, I want to note that so it doesn't come back on me. We did let the customer know that this motor is starting to show signs of wear. And again, here you can see this as well, this discoloration from the oil. If I was going to replace this motor, the information I'm going to need is right here in the tag. This is a 1/2 horsepower, 115 volt motor. It also uses, we need the RPM of this motor, and this motor is, it's on here somewhere. Oh, here's the amps, is 7.1 amps, and the RPM being 1,000 RPMs, rotations per minute. So when I go to get the new motor, I don't need to take this motor with me and take it and dump it on the counter. I need to get 1/2 horsepower, 115 volts, 7.1 amps, and RPMs being 1,000 RPMs. Anytime you change a blower motor, you also put a new capacitor in. Usually the new capacitor is going to be a different size for the motor anyways. But if my motor's good, I also want to check my capacitor. So I'm going to discharge it with a 20,000 ohm 5-volt resistor, then pull the wires off and make sure it reads correctly. This one's rated for a 7.5 microfarad capacitor. Hook my meter on microfarads and hold it firmly on one side and the other and see if that reading matches it. If it doesn't, if it's out of range, we'd want to replace this. This has a plus or minus of 10%. So it could be 10% higher than 7.5 or 10% lower. Notice I said percentage and not microfarads. So if we do the math, you can calculate it. We also want to make sure we use a 370 or we could use a 440. The capacitor can be larger but never smaller. These are things that we want to check. Also, if we notice there's a significant amount of rust here, we'd want to note that on the invoice as well. So what we're going to do is move this motor out of the way. And we're going to take a look at this blower wheel and housing. So this blower wheel is really dirty. What I would do in maintenance is take this out and clean it. When I take it outside to clean it, I would take a water hose and spray a water hose down at this angle and spray every single fin while turning it by hand. I would take it, dump the water out, and then I'd take and wash it again. And I'd wash it over and over and over until I got all of these fins that are clean. What we're going to do is go ahead and take it out of the housing so we can see it entirely. Now when I'm washing the blower, I like to always wash it in the housing. But if we need to replace the blower wheel, we'll need to pull it out of the housing. And this particular brand makes it very tight, so it's going to be a little bit of a pain to pull it out, but it's all right. Now as I'm pulling it out, notice which way the fins go. I have my hub on this side and my motor mounts on this side. It's very important we put it back in that same direction. If I pull this out, we can see that there's all kinds of dirt in here. I also see these little bit of stains here on the side. I can tell this has been washed before. Somebody used some kind of a chemical on this once before, but it needs to be washed again. This is our blower wheel. A lot of people call them a squirrel cage housing or a squirrel cage, hamster wheel, squirrel cage wheel, all these different words that we use, but it still means the same thing. This is the blower wheel. If you need to replace this, this is going to be a part that you can take in with you. You can get the numbers off of it, but I found it's best just to take this wheel in and say, I need another one of these wheels. Ideally, I could go to the Rheem supply house and order a wheel with the model and serial number, getting exactly what I need, but you don't always have that luxury. So if you take this wheel in, you want to make sure you get it the correct width this way, the correct diameter this way, make sure you have the correct shaft size so that you can move it. And sometimes the new wheels will be heavier than the old wheel, so it'll affect the longevity of that motor. But here we can see that there's a lot of dirt inside of these fins. I don't know if it's going to show up on the camera or not, but each one of these is just really, really dirty. All of this needs to be cleaned out. So that's the basics of our blower side. We're going to go ahead and go through the rest of that operation. We're going to start with the burner, and we're going to cover some of those topics next. So in our next sequence of destruction, we're going to start off with our pressure switch. This particular model has 2 screws at the very top, and of course almost everything on here is 1/4 inch. We're just going to take these 2 screws off, and you're going to see this drop pretty much straight down. Right, 2 screws are free. Now we have the mounting of this free. So we have a hose coming to it. So when this inducer fan motor runs, it pulls a vacuum through this hose to our pressure switch, or I like to teach it as a negative pressure switch. It activates on negative pressure. These 2 terminals are normally open. When this motor runs, it pulls a vacuum, pulling a diaphragm, closing this switch. So if we want to disconnect this, we just disconnect these 2 wires. And we could actually check this with our meter, setting it to ohms. We can set it to ohms, run our fan motor, and we should see in ohms, this would be 0 ohms. The switch would be closed, and when we shut this motor off, it would show OL, or infinite resistance. The switch is open. We could also check this with voltage. We could leave this wires connected, just pull them down a little bit, and if we check voltage across here, with this fan running, the voltage should go to 0. It's a closed switch. When this fan motor stops, the voltage should show usually 24 volts. We're going to take this loose, and we're going to take this loose. And what we're going to do is just pull this little hose off. Now this hose we need to be very careful with. I'm going to pull it off with the inducer motor completely, but this hose ends up getting cracked and dry rotted over time. This is going to be one of the things that you have to replace. So these hoses can also get stopped up. You can get bugs or other buildup in there, and it can clog this hose up, and it won't pull a vacuum to our pressure switch. Also, we're going to take one of these pressure switches apart so we can see what's inside. So here we have our pressure switch, and this is just a micro switch, and then we have the connector for a hose here. So once we take this piece off, it's just a hollow housing, and if we notice, there's also a little spring right here. The spring would be in the center of this diaphragm and held right in the center of that piece right there. So with that removed, it pulls a vacuum, it moves this diaphragm here. So we're going to take this loose, just going to pull it loose. Notice there's a nice little seal on it. That's what holds that vacuum. And there's this little button on the end. So this is center plastic is metal. This is a rubbery type material, membrane, and this keeps pushed on right here. So when it pulls a vacuum, it pulls this down, and this switch then closes. And when the vacuum stops, the spring pushes this back in that keeps the switch pushed open. So we pull a vacuum and it closes. Very simple. This is usually what wears out internally. You don't repair this, you just replace it. Just wanted you to see what it's like. But over time, this material, I don't know if it's some type of silicone, what it is, can break down. Or also you can get, if you have the system installed incorrectly, you can get condensation up in here, and that moisture can cause issues. It's very simple to replace these. Just 1 hose, 2 wires, and 2 screws. But they all have very specific settings. They're measured in either inches of water column or water column pressure factor. This one's a 0.35 inches of water column. So we could actually put that tube, we could put a T on this tube, and we could measure how much pressure we have, negative pressure or vacuum we have going to this pressure switch. If you don't have enough pressure for the switch to close, you need to be looking at this component. If you do have enough pressure for the switch to close and the switch is not closing, you need to be looking at the hose or this component here itself. So one of the things that's pretty easy to replace, and you can't bypass these. The IFC knows if you try to bypass this, it won't let it, because it knows it should only be open in the proper sequence and only closed in the proper sequence. So you don't bypass that, and really just don't bypass any safety components. Good habit to have. So now we've removed the inducer fan motor, the pressure switch. We're going to move over to this inducer fan motor. So this is our motor. This is going to be pulling a draft through the heat exchanger, and it induces or starts a draft in the flue pipe. Now it's very important to remember that this motor is not pressurizing. It's not forcing the gases out of the flue pipe. This inducer motor helps pull, it does pull the draft through the heat exchanger. It helps start the draft, but it does not pressurize that flue pipe. It's still natural draft and relies on natural convection, the heat being less dense rising up. A lot of people think this is forcing the exhaust at the flue, and that's not true. I've seen before a bird nest completely stopping up the flue pipe, and this not have enough back pressure to set off that pressure switch. So that's important to keep in mind. This little fan on this side keeps the motor cool, but on the other side it's another blower. So what we're going to do next is we're going to go ahead and take that off. There's going to be 2 wires here. Oh, and that one was very loose. Number 1 cause of electrical issues is loose connections, and that connection is extremely loose. So that's something we would want to tighten up. This one's good and tight. That's how we like it. But I'd want to make sure with this particular model, 115 volts. So if you saw this motor was not working, you had everything calling down there, you'd put your voltmeter here and here. You would check for 110 volts. If you were not getting that, you had a problem on this side. If you were getting 110 volts and the motor's not working, you look at the capacitor or the motor. And this particular motor does not have a capacitor on it. We're going to take this motor off so you can see what's happening on the back side of that. And I did forget this one last little wire. There's a ground wire right here. So we can either take the ground wire off where it connects here or off of the motor. So I'm just going to pull it off of where it connects right here. So as I pull this off, one thing I really want to point out is notice this type of insulation right here. This is really a gasket material. It's a high temperature fiberglass. And because I pulled this off, this is now damaged. So I'd have to replace it. If you're going to pull this off and reuse it, you want to be very careful that you didn't damage it, or be prepared to have another replacement gasket in. So if I put this back in with this big tear right here, it could be pulling air through the side here and not protecting it. You also can't use any kind of rubberized because the temperature of this could be very hot and it could cause it to melt. There's a lot of what ifs, high temperature this and that. You get into lots of gray areas. I like to go back with what the manufacturer designed. So this is our inducer fan, or inducer draft motor. It's pulling a draft through the heat exchanger. If I turn this, it turns pretty free, but notice how it comes to an abrupt stop. That tells us there's probably some damage to the bearings. The bearings are probably overheated. One of the things I like to do when this motor runs is I'll take and put a mechanic stethoscope against this and listen to the sound of the bearings. In the old days, we used to actually take a screwdriver, put a screwdriver against it and put it up to your ear, which does work, but looks really funny in front of your customers. So the mechanic stethoscope I like, you put it in the ears, metal rod touches it, you can hear the bearings. Can't really describe how a bad bearing sounds, but over time you hear enough good ones and you'll know when something doesn't sound right. This one I can spin it and I can just hear that it doesn't sound right. On this, notice that this wheel is very clean. Most of the time they're going to be in really good condition. If you have one of the soot built up in here, you're having a problem with the combustion or the gas pressure in that system. Something needs to be adjusted. But usually these are pretty clean. Now because of all that heat running through here, it's almost impossible to change just this wheel. So when this motor goes bad, you change this entire housing. It's inducer draft housing, inducer fan housing, combustion blower. All these are words used for this, but it's this whole entire housing that we replace. What I want to point out on this particular model is we have some stains right here. And most likely what that is there was water coming down to the flue pipe from the cap or something like that was probably causing these stains over time. On this particular one, it's not too much to worry about, but if you notice how that moisture is in there, how that can easily get through that hose, causing the hose to clog up or that pressure switch to clog up. But this is our inducer draft motor. One of the things we want to do when we're doing maintenance, other than listening to the sound of the bearings, we want to check the amp draw. And so this one is a 1/20th horsepower, but it's rated for 1.7 amps. So what we want to do is, while this is running, clamp our meter around one of these wires and see to make sure it's not drawing more than that. If it's drawing more than that, we're going to need to replace this motor or maybe check the heat exchanger to see if there's some other problem. Now, this motor here runs and it pulls an exact amount of air, and this hole is a very precisely made hole. So we know if we're moving this motor at that RPM, we know exactly how much air we're pulling through here. That's why these new types of jets don't require any kind of air adjustment. If you set the gas pressure, the air factor is already set for you. Behind this, we have our heat exchanger. I'm going to turn this to the side. Heat exchanger, right in here, this is a collector box. So our main fire is going to burn here to the secondary collector box, and we go through here to make it more efficient, and all the gases gather together right here. So this inducer fan motor is pulling from all of these tubes equally. So now that we have this exposed, we can see there's another component here. Now manufacturers put this component in a few different places, but it's always going to be on this panel side, but the sensor is going to be on the back side. And what this is a primary limit or a high limit switch. There's going to be two wires here, usually 1 or 2 screws, and it could be here or in the center, on the sides, many different locations. But if we turn this around, we can actually see that this sensor is going to be installed right above our heat exchanger. So this is our primary limit switch. If this limit switch opens, it shuts off the combination gas valve so that these don't get hot. If this limit trips, your first thought needs to be airflow, airflow, airflow. If this limit opens up, usually you're not getting enough air across the heat exchanger. A lot of new techs want to think that they need to have a problem with the gas pressure, and no, you need to be thinking airflow first. Dirty filter, blower not on the right speed, it's dirty blower wheel. Maybe the evaporator coil that's up here gets clogged up. All of these things, you're not getting enough air. So when this heat builds up, this limit switch will open. So these switches do go bad, especially when you have the evaporator sitting on top of it and it leaks water. and it causes this to corrode out. So what we're going to do is we're going to pull this component out so you can see really quickly what it looks like. And here's what our primary limit looks like. This side is going to be on our control panel side. We have this gasket material, and then this is what's on the side of the heat exchanger, on the air side. So if this gets too hot, this trips. Now it's very important that you note how this comes out, because you want to put it back in the same way. If the sensor was facing down, you want the new one facing down. If the old sensor was sideways on this direction, you want it the same way, or if it was on this direction, or if it was down, up, however it was, the manufacturers have engineered precisely how it goes. Some of them have little fan diverters, little piece of metal that blocks the airflow. However it came out, you need to be very careful to put it back in that same way, because that could be a cause of what we call a nuisance call for these limits tripping when there's no problem in there. So make sure that goes back precisely how it is. And it has all these numbers rating on here. This one limits at 170 degrees Fahrenheit minus 120. That means it will reset 20 degrees less. So 70 minus 20, so we're looking at 150. So it resets at 150. That's our primary limit. So we're going to unplug it, and we'll take it out of the way. Now as we go through our list, we're going to go down through here. The next big thing we see is our combination gas valve. It's a pretty simple component. We only have 2 wires and our ground on here. So this is our combination gas valve. Gas pressure comes in, and this one had a flex connector coming through the side, and it really should be hard piped completely outside this furnace with a drip leg on this side. So this wasn't really installed correctly, not big of a deal for us. These 2 wires, during a sequence of operation, the IFC will send 24 volts here, allowing this to open and gas to flow through this component called the manifold. So we're going to take this component off next. So we're going to unplug these 2 wires, and we want to make sure we put them back in the same exact place that they were on. So this one's on the side, and we have the yellow on the top and the blue on the bottom. So we'd make a notation of that, and then we would take and pull these wires loose. We want to make sure we grab the wire by the terminal and not the wire itself. So we pull this one off, and I wiggle it back and forth to get it loose. It's really stuck. And we'll also pull off this ground wire as well. Now instead of unscrewing this combination gas valve, I'm going to take off the manifold as well so we can get to everything we want to see. So it's just going to be 4 screws holding this entire manifold on. Now we have our combination gas valve, which is a very simple component, and it's going to have a few little ports here. One is going to be the adjustment port for the gas pressure. It's a combination of a solenoid valve, which we have our low voltage in here that opens and closes, and secondly as a pressure regulator. So behind this cap is how we adjust the pressure. There's 2 kinds of pressure we have: incoming gas pressure. So in this very port on the top it says in. We can take that port out, we put an adapter there, and we can check the inches of water column incoming pressure. And on the other side, it has the same exact port. We can put the same adapter on, and this is going to be our output pressure, or what we call manifold pressure. So we want a set amount of manifold pressure on this. So that's our combination gas valve, very simple component. We have to make sure we have gas available coming in and gas coming out as well. But also on this manifold, we have this component right here. And these are usually made of brass, but not always. So we're going to unscrew this, and it has a very special name. And one of the names is called a spud. I have no clue why it's called a spud, but that's the name that we call it. And this one is on there very tight. Try this other one. It's best to use a wrench, especially if it's brass, but this is going into the dump later, so. All right, so this component right here is called a spud, and in the spud there's a hole. And that hole is called an orifice. So some people just call this whole piece an orifice. That's fine. But this spud has the number 42 written on it. 42 is the size of that hole of this orifice. So sometimes you're going to have to change these orifices out, especially if you're at altitude or you're converting it from natural gas to propane. You have to follow the manufacturer's instructions on what size and when to do that. So just because it came with an orifice size doesn't mean that that's the size you're going to be using. especially when you get into combustion analysis, follow the manufacturer's instructions, but that is a spud and the hole in the center is an orifice. What this orifice does is lines up here in our jets or our burners. There's many different types and styles of these burners, but these burners are called in-shot burners. In the field, a lot of people just call them jets. It's just a habit that's easy to get hung up in, and they look like jets. This particular style looks a little different than others. This one, Rheem and RUUD manufactures theirs all in one entire piece. It's all together. So this has 3 individual burners, and it has 3 of these spuds and orifices shooting gas into it. Now these burners have a main objective, to mix the primary air and the fuel. So the gas shoots in the middle, and the primary air is coming in these little holes right here. And this burner's job is to mix the air and the fuel so it burns efficiently. So it's going to mix the air and the fuel inside the burner, and it aims it towards the holes in the heat exchanger in the back. Once we pull these pieces out, you'll get to see that soon. This one uses an electronic ignition system to ignite that flame, and we also use a flame sensor so that we can check to prove that we have a flame through a process called flame rectification. I'm going to pull this out as one full assembly so you can see that easier. Now here we have the burner assembly. The jets or the spuds shoot the gas in the center here, mixed with primary air, mixes it inside of this tube or these burners, in-shot burners, and then it directs that flame towards the heat exchanger. Here's our spark igniter. So we're going to send our gas across the spark igniter. If you notice, the spark igniter here has a little bit of a burnt spot because the flames are always burning against it. The idea is if we send gas through here and we're arcing a spark across here, it ignites that flame. Then these little tubes here are all connected. These are called crossover burners. So the main burner is coming across here and allows some gas to leak over here to light this one and then to again light this one. This is our spark igniter. It has only one wire to it. The other one is mounted to ground. If we take this spark igniter loose, leaves just our burners. Now this is our spark igniter. This is going to be a high maintenance component right here. If there's a lot of little black pieces on here, what we're going to want to do is clean that. Now this is where we're going to use a soft style Brillo pad to clean this to make sure we get all of that black off of there. We never want to use sandpaper or sandcloth on this. This is not what we use. The reason is the sand can gouge into and leave grooves in this. Also, it can leave the silicone coating on that. The silicone gets heated up by the flames and it really leaves a glass coating and it doesn't allow for it to arc correctly. The gap between these two is also very important. You want to make sure that you don't spread these out or get them too close together. So when you're cleaning these, you want to be mindful not to bend these forward or backwards. When I'm inspecting this, I really just want to inspect the porcelain to make sure this porcelain doesn't get cracked or brittle or broken. Other than that, it's very simple. One wire comes up to this and it just arcs across the two. So make sure they're grounded good, make sure they're cleaned good, make sure there's not a crack in that porcelain, and you're really good to go. The other component we have on the opposite side is our flame sensor. Just one wire on it as well. What we're going to do is we're going to take it off next so we can see that component. This is our flame sensor. It also has to be cleaned the very same way as our spark igniter. We can see all this different discoloration on here and even some rust on there. So that needs to be cleaned off. This has to get a good signal against that flame through flame rectification. We'll talk about it in another video. Again, do not use sandpaper on this. Do not use any type of sandcloth. It gouges these out. It causes damage. When it makes use with one of those Brillo pad, abrasive pads, something like that, we can clean this off really well. And when I get it cleaned off, I don't even like to touch it. I don't want any of the oils from my hands to get on there and cause any issues with it. But again, the same thing, we check the porcelain, we make sure this connection's good, and there's several ways of checking these we'll get into later, but that's the most important on the maintenance of this furnace is cleaning that flame sensor and cleaning that spark igniter. So these two components, one's on one side, we ignite the flame on one side, we check to make sure we have a flame all the way across on the other side. Now that we have that out of the way, we can see the tubes for each of our burners. So this is where the flame's going to throw inside that heat exchanger, they're burning in those tubes. And the flame only burns right about in here or so before it burns out. The rest of this is just hot gas. The hot gas collects here. We separate the hot gas through all these smaller tubes back to this collector plate. So now notice right where the burners are, right where the flame goes into that heat exchanger, we have 1, 2, and 3 sensors here. These sensors are very important, and these sensors are called flame rollout switches, and they are manual reset for a reason. So we're going to pull one of these off so we can get a better look at it. So here's the flame sensors. They're wired in series, into one, into another, out of the other. But one thing that's really important about this is there's a manual reset. Now this is just bimetal, so when the flame was to roll out of the heat exchanger, that flame would come up next to one of these flame rollout switches, and the flame would cause this bimetal to get hot. And when it gets hot, it makes this little click noise, which pops the reset. It opens these wires. Once these wires are open or broken, the IFC knows, hey, we have a problem, and it shuts down the combination gas valves. It shuts down the entire system. Now, as a technician, you have to come out and you have to manually reset that limit switch, the fan rollout, sorry, the flame rollout, so that it resets. Now, you don't just press that button. Here's what I want to stress. You don't just press that button. You also need to find out what caused it. What caused the flame to roll out of this heat exchanger? If that flame is coming out of this heat exchanger, that's a big problem. We want to know why. What caused that to happen? There's many things that cause that. Usually a combustion analysis checks that. We want to check that heat exchanger. We want to check everything about it. We do not just want to reset that. I've never seen one of these limits trip without having some kind of an issue. Find that issue and solve that issue. So what we're going to do next, we're going to take the last of these components off, and then we're going to pull this heat exchanger out of this unit. Now here we have the heat exchanger itself. This is the guts. So if somebody says, can't you just change out the heat exchanger? And the answer is yes, you can, but it does take a significant amount of labor to make sure this happens. So this is our heat exchanger. Everything's built around it. Now these should last a lifetime. Most of these have 20-year warranties on them. And if you set it up, have the proper airflow, the proper maintenance on this, it should last at least 20 years. Now the problem is we want to check to make sure there's no leaks in this, because if air leaks from the heat exchanger from the inside to the outside, that could cause carbon monoxide poisoning to our customers. So we want to make sure we check that. But this is our heat exchanger. And we noticed right here where this connection is, that's a notorious place for these to leak, as well as right here along these connections. Where these pipes connect together is a notorious place for them to leak. Again, right here is a notorious place for them to leak. And also we want to check the back of the burners right here. If somebody sets this up to overfire, it'll actually burn out right here. So the blower is going upflow. It's pushing the air up through the heat exchanger this way, the primary first, then it goes across this part of the heat exchanger. And then we pull all the gases together through these tubes to this little collection box, and this is where Inducer Fan is, that's pulling that draft of the whole thing. So this is our heat exchanger. So once we move the heat exchanger, all we have left is a cabinet with just some wires in it. So we're going to go ahead and pull the last of these wires out, and there's two little plugs right here. And I can undo these plugs. Hopefully they won't break on me. One and two. And what we're going to do is take the plugs off the top side as well, so we can completely remove all the wiring from this, and I'm going to lay the wiring out so you can get a better idea of how the wiring in this system works.